ISL6257, Highly Integrated Battery Charger Controller for Lithium-Ion and Lithium-Ion Polymer Batteries, Intersil Corporation. Welcome to this training module on Intersil ISL6257 battery chargers. This training module introduces the operation and applications of the ISL6257 battery charger. Designed to meet the NVDC-I requirements for better efficiency and longer battery life, Intersil's ISL6257 is a narrow voltage direct current charger controller for lithium-ion and lithium-ion polymer batteries in notebook computers. The device is optimized for this application, allowing customers to run laptops at much lower battery voltages, providing better efficiency, longer battery life, and improved thermal management. The ISL6257 offers the best overall accuracy and features narrow VDC output, which allows the system to operate from a regulated charger instead of the adapter. It promises plus or minus 0.5% charge voltage accuracy from -10 degrees C to 100 degrees C for precise charge voltage, increasing battery life. The device also provides a plus or minus 3% accurate battery charge current limit for precise charge current control, allowing maximum charge rate and further extending battery life. The device provides a fixed 300 kHz pulse width modulated synchronous buck controller with diode emulation at light load. This constant frequency simplifies the design process. Diode emulation improves efficiency and prevents adapter voltage boosting. This charger controller has a fast input current limit response to prevent overcurrent shutdown of the adapter. A plus or minus 3% accurate input current limit provides precise input current and allows higher charge rates without exceeding the adapter's current limit. This device also has a plus or minus 25% accurate battery trickle charge current limit. ISL6257 includes all of the functions that are necessary to charge 2 to 4 lithium-ion and lithium polymer batteries. A high-efficiency buck converter is used to control charging voltage and current. CH-LIM input is used to control charge current, and V-adjust and cells input are used to control charge voltage. The ISL6257 charges the battery with constant charge current until the battery voltage rises to a programmed charge voltage set by V-adjust and the cell's input after the charger begins to operate in the constant voltage mode. The enable input allows shutdown of the charger through a command of a microcontroller. This might be used when the battery is in an extremely hot condition. The enable pin is used to shut down the charger. The synchronous buck converter uses an external in-channel MOSFET to convert the input voltage to the required charging current and charging voltage. The ISL6257 employs a fixed frequency PWM voltage mode control architecture with a feed-forward function. The feed-forward function maintains a constant modulator gain of 11 to achieve fast line regulation as the buck input voltage changes. When the battery charge voltage approaches the input voltage, the DC to DC converter operates in dropout mode, where there is a timer to prevent the frequency from dropping into the audible range. It can achieve a duty cycle of up to 99.6%. An adaptive gate drive scheme is used to control the dead time between two switches. The dead time control circuit monitors the L gate output and prevents the upper side MOSFET from turning on until the L gate is fully off, preventing cross-conduction and shoot-through. The ISL6257 uses a high-accuracy, trimmed band-gap voltage reference to regulate the battery charging voltage. The V-adjust input adjusts the charger output voltage. The V-adjust control voltage can vary between 0 to Vref, providing a 10% adjustment range. Providing a 10% adjustment range on CS on regulation voltage. The overall voltage accuracy is better than 0.5%. Other battery charge voltages can be set by connecting a resistor divider from Vref to ground. The resistor divider should be sized to draw no more than 100 microamps from Vref or connect to a low impedance voltage source like a D to A converter coming from a microcontroller. The CH-LIN input sets the maximum charging current. The current sense resistor is connected between CS op and CS on. Other battery charge current sense threshold values can be set by connecting a resistor divider from Vref, or 3.3 volts, to ground, or by connecting a low impedance voltage source like a D to A converter from a microcontroller. Without input current regulation, the source must be able to supply the maximum system current and the maximum charger input current simultaneously. By using the input current limiter, the current capability of the AC adapter can be lowered, reducing system cost. The ISL6257 limits the battery charge current when the input current limit threshold is exceeded, ensuring the battery charger does not load down the AC adapter voltage. AC set pin is used to detect AC power by connecting a voltage divider. AC PRN is an open drain output and is high when AC set is less than V threshold fall, and active low when AC set is above V threshold rise. Similarly, DC adapter detection is also done using DC PRN connected through a resistor divider. DC PRN is an open drain output and is high when DC set is less than V threshold fall and is active low when DC set is above V threshold rise. The ISL6257 has an internal low dropout regulator which supplies a constant 5 volts at 30 milliamps of current. It also has the feature of low power shutdown mode. Driving EN low shuts down the ISL6257. EN can be driven by a thermistor to allow automatic shutdown of the ISL6257 when the battery pack is hot. In shutdown mode, the DC to DC converter is disabled, and the VCO-MP and the ICO-MP are pulled to ground. The phase voltage rings due to the high impedance of both FETs when they're off. Adding a snubber, which could be a resistor in series with a capacitor, from the phase node to ground can greatly reduce the ringing. In some situations, a snubber can improve output ripple and regulation. The snubber capacitor should be approximately twice the parasitic capacitance on the phase node. This can be estimated by operating at very low load, approximately 100 milliamps, and measuring the ringing frequency. If the combined battery charge current and system load current draws current that's equal to the adapter current limit set by AC LIN pin, the ISL6257 will reduce the current to the battery or reduce the output voltage to hold the adapter current at the limit. A filter should be added between the RS1 and the CSIP and CSN to reduce switching noise. The filter roll-off frequency should be between the crossover frequency and the switching frequency. The voltage error amplifier controls the output when the battery is not drawing current and the input current is below the limit. Under these conditions, VCOMP controls the charger's output because the two current error amplifiers, GM2 and GM3 output their maximum current and draw and charge the capacitor on the ICOMP to its maximum voltage, which is limited to 1.2 volts above VCOMP. With high voltage on ICOMP, the minimum voltage buffer output equals the voltage on VCOMP. When the battery voltage is less than the fully charged voltage, the voltage error amplifier goes to its maximum output, which is limited to 1.2 volts above ICOMP, and the ICOMP voltage controls the loop through the minimum voltage buffer. The figure shows the charge current control loop. The compensation capacitor, CI-comp, gives the error amplifier, GM2, a pole at a very low frequency, which is many times less than 1 Hertz, and a 0 at FZ1. FZ1 is created by the 0.25 times CA2 output added to ICOMP. The loop response has another 0 due to the output capacitor's equivalent series resistance. Here is the recommendation about the selection of an inductor, capacitor, and MOSFET connecting externally to achieve better accuracy and performance. Here shows the typical operating performance of the ISL6257 and frequency response of an LC output filter. The ISL6257 provides plus or minus 0.5% charge voltage accuracy from minus 10 degrees C to 100 degrees C for precise charge voltage, increasing battery life. This device also provides a plus or minus 3% accurate battery charge current limit for precise charge current control, allowing the maximum charge rate and further extending battery life.